This week we are starting Newton's laws of motion. Um, from now on in physics, we are dealing with forces. Okay? And force are measured in newtons. Okay? Newton is a unit of measurement of force. So let me give you an example. If you're holding an apple in your hand, you're basically applying 1 Newton of force on that apple. This is how much 1 Newton is. Okay. Now let's go to its first law, Newton's first law. Um, Newton's first law is quite simple. A body will remain at rest or continue with constant velocity unless acted up on by a net force. Okay. Remember, a body will remain at rest, remain stationary, or constant velocity. Okay. So what does it mean by constant velocity? Just remember, when we're talking about constant velocity, it means acceleration is zero. So Newton's first law basically tells us, unless there is a net force, the acceleration of an object will be zero. Okay. Yep. Now, okay. Now, what's happened is I'm expecting everyone to have copy down. You have to manually copy down Newton's first law on your notes or on your cheat sheet, because in year 12, um, the problem is in year 12 final exam, sometimes the examiner will ask you to use Newton's first law to explain blah blah blah. When in the question they mentioned Newton's first law or use of Newton's first law, it is expected that students basically written down the definition of Newton's first law. So I'm not asking you to memorize it, but at least put it on a piece of paper on your cheat sheet. Okay, now have a look at this example. Okay, so in figure ABC, initially I have a Batman standing on top of a car, a moving car. Okay. The speed of the car will be, let's make it say 15 meters per second, moving to the right. Okay. So question one is, okay, then what's happened? Oh, sorry. Then what's happened is Batman jumps up. Okay. Then where is Batman? Okay. You need to. Well, I haven't drawn Batman yet. I'm going to draw Batman later. Okay. Now, question one is, okay, at figure A, the car moves at 15 meters per second. What is the speed of Batman? Just think about it. I'm going to write down the answers now. Okay. The velocity of Batman will be the same, 15 meters per second to the right. Then the second part is when Batman jumps up, what is its horizontal speed? Think about it. So when Batman is on the air, okay, the car is still traveling at 15 meters per second. Okay. Batman would also traveling at 15 meters per second. Of course, assume there's no resistance. Okay. Assume there's no air resistance. This is because initially Batman is at this speed, which is a constant speed. Batman jumps up and falls down. While Batman in the air, there's only vertical forces. There's a force Batman jumps up, and there's a force of gravity pulling Batman down. But horizontally speaking, there is no net force. There's no force acting on it. Thus, Newton told me horizontally there will be no acceleration, means there will be no change to its velocity, with constant velocity, no acceleration. So at this time, the Batman will be still traveling at 15 meters per second because there's no horizontal force pushed or put on it. So assume there's no friction. In figure 3, Batman will return to the top of the car. Yep, where it, yep, like this. Okay, so yep, this, okay, and this is what's happen exactly what's happened when a skate, yep, when people play skateboard when they jumps. Have a look. So when he jumps and when he returns exactly at the same position on the skateboard as he jumps because according to Newton's first law, there's no horizontal force pushing on him. He will travel at the same speed as the skateboard. Okay, let's just have a look at this again. Yep, done. Now let's look at another example. We have a car traveling at a constant speed of 60 kilometers per hour. The friction of the road is 500 newtons. That's a friction resistant force. What is the force applied to the car by the engine? Okay. Now this is a typical Newton's first law question. Now let me draw a diagram. Okay. Now I have a car traveling on a road. I have a car traveling on a road. Now let me draw the forces. So we have a friction force. Okay. Well, let's start reading the question. Okay. Now it travels at a constant speed of 60 kilometers per hour. So the velocity is 60 kilometers per hour. It's constant, means the acceleration is zero. Okay, zero acceleration. Okay, according to Newton's law, okay, the net force is zero. Okay, there's no net force. Okay. However, the friction of the road is 500 newtons. So the road pushes, okay, the car in the opposite direction because friction is always acting on the opposite direction, okay, which is 500 newtons. Okay. What is the force applied to the car by the engine? Okay. So the solution is, now since there's no acceleration, so there's net force is zero. The engine pushes the car towards the direction, okay, the driving force of the car. However, there's no acceleration, means the net force has to be zero, so these two forces must be the same. So the engine must apply 500 Newton forces exactly to cancel the friction, so the acceleration is zero and the car is maintaining at a constant speed. The car is not speeding up or slowing down, it maintains constant speed because the net force is zero. Okay, yep. So Okay, have fun.